Okay, so today we're going to talk about sets. So a set is a set is a collection of items referred to as elements of the set. Okay, so basically a set is a collection of elements inside the set. Okay, so let's say we have A equals 1, 2, 3. So these guys here, this 1, right? 1 is an element of A, and that's the little symbol for element right there. But don't worry about that. Just 1 is an element of A, and 3 is an element of A, right? Etc. Okay? So now let's move on to subset. Okay? So let's say that B is a set, right? So B is a subset of A written like this, okay? If every element in B is also an element of A. Okay, so let's say we have A is equal to 1, 2, 3, 4, right? And B is equal to 1, 2. We can see that every element in B is also an A. So B would be a subset of A, right? And we could, let's draw a little picture. So let's say we have something like this. So this is our sample space, and we have A here. And A has 1, 2, 3, 4, right? So this is A. So B would just be this guy here. This would be our B. And you can see that B is totally contained in A, right? So that says that B is a subset of A. So what we're going to be doing in this class is using Venn diagrams to help us out a lot with the pictures and stuff. Okay? So now let's talk about set operations. Okay? So this one, A union B, is equal to X such that X is an element of A or X is an element of B. Okay? So X can be in either A or B to be in this set A union B. And the intersection is equal to X such that X is in A and X is in B. Okay, so I'll give you some examples here. So, and here's the picture. Okay, I'll give you guys a picture of what these guys look like. So A union B. So this is our sample space S. This is A, and this is B. Right? So A union B is anything in A or B, right? So this is our A union B. And over here, let's have our sample space S, A, B. This would be the intersection where they share. So both elements have to be in both A and B for it to be in the intersection. Okay? So let's do an example. So let's say A is equal to A, B, C, D. And B is equal to C, D, E, F. Okay? So A union B would be equal to A, B, C, D, E, and F. Right? It just has to be an either or, but A intersection B would only include this element C and D. Okay? So now let's move on to the complement. So basically we have our sample space, S, and we have our set A. The complement is basically everything in S, but not in A. So it's all these guys. So everything in S, but not in A. So that's literally what we're right. A complement is equal to X contained in S such that X is not in A. Okay, so we can do an example here. So if S is equal to A, B, C, D, E, F, G, and A is equal to A, B, C, D, then A complement would be E, F, G. Okay? Just all the stuff in S, but not in A. That's the complement. Okay, so last thing. Now we're going to talk about the Cartesian product. Okay, so this is basically A cross B, where A and B are sets, which is equal to, so this is an ordered pair, where A is in A and B is in B. Okay, so let's say that A is equal to AB and B is equal to 1, 2, 3, 4. Oh, let's just do 1, 2, 3. Make it a little easier on ourselves. Okay. Okay. So A cross B would be equal to the ordered pairs A1, A2, A3, B1, B2, and B3. All right. And another example is if S is equal to heads, tails. When we get into probability, this is going to be neat. So that means S cross S is going to be equal to H, 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 T, T, H, and T, T. Okay? All right.